Okay, so 7.4 is about converting multiplication problems to addition and subtraction problems, or addition and subtraction problems into multiplication problems. There are a couple of reasons that we would want to do this, right? This is just another tool in our toolbox. Sometimes that's going to help us if we are doing calculus. We want to take a derivative or do an integral, and one is easier to evaluate than the other. Sometimes we can use it to rewrite expressions because alpha minus beta over 2 will be on the unit circle when alpha and beta themselves are not. So we can use these formulas to help us find exact values on the unit circle. And we're going to see that usage today. So what we're going to practice is we're going to practice just with the formulas and the substitution, and then we'll practice with actual numbers for angles and using the unit circle to evaluate. Yeah. So we'll start with number 1 on your worksheet, which you should have in front of you. We'll zoom in. Perfect. Okay. So looking at number 1, it says negative cos 6b times sine of 2b. And the directions say write each product as a sum or a difference. So this is a product to start with. I want a sum as my answer, so this is product to sum. So I go look at the product to sum formulas, and I'm looking for cos times sine. Cos times sine. And I see cos times sine is the last one, and it's sine of the sum of the angles minus sine of the difference in the angles. So I'm going to write the formula down, and then we're going to substitute the angles in. So I know that this first angle we're going to call alpha. Second angle we'll call beta, because that's what our book does. Yeah. And the formula says that cosine times sine can convert to an addition problem. The minus 2 is not part of the formula, so it's going to hang out in front. And then I'm going to write the formula down. Yeah. And the formula says 1/2. Yeah. And then it says sine of the sum of the angles minus sine of the difference of those angles. Alpha, beta, alpha, beta. And all I've done is I've taken this chunk here and replaced it with the formula from the book. Yeah? Nothing fancy. Direct substitution. The book says those two things are equal. I can replace cos times sine with 1/2 sine minus sine. Yeah? And then I'm going to substitute the alpha and the beta from our problem. Because I don't have alpha and beta, I have 6b and 2b. So I'm going to make that substitution. So alpha is 6b. And beta is 2b. Grab the formula from the book, write out the structure of the formula, substitute the angles we're given. Yeah? There's one more thing I should do. Now that I've made the substitution, what should I do last? Yes? That is a great question, Yaya. That's because I am not awake this afternoon. Thank you for catching that. Don't be sorry. You caught my mistake. Thank you. What should we do afterwards? I'm not done yet. I can't turn that in. That's not a complete answer. What should I do? It's correct, but my math teacher would be unhappy with me. What should I do? Simplify. Yeah, with confidence, Bonnie. Yeah, simplify. Clean up your work. Yes, it's correct, but now we should make it pretty. And we see some stuff that will simplify. I see a 1/2 and a 2. I know those 2's are going to cancel. I'm just going to have a -1 in front. Inside, I see a 6b plus a 2b. And I know 6 plus 2 is going to give me an 8b inside that first sign. Inside the second sign, I have 6b minus 2b, which is a 4b. So we can shorten this a little bit. I have a -1, which is just a minus sign. And then I have a sign of 8b minus a sign of 4b. There's probably one last thing I could do, because I don't like parentheses if I don't need them. What could I do as my last step? Starts with a D. Distribute. Let's distribute that negative sign through. Yeah. So negative times positive is negative, so negative sine 8b. And then negative makes plus sine 4b. Happy face. Yay. And most often we would do that if 8b and 4b are on the unit circle, but 6b and 2b are not. And we're going to see an example of that in just a minute. Good. Let's do another one. Yeah? Let's do number 3 since it's up on the board. Yeah. Number 3 says sine of 9b times sine of b. I'll do it faster this time. Same process. This is my alpha. This is my beta. I don't have a constant in front, so I'm just going to grab the formula for sine times sine. Sine times sine, which is the third formula on our sheet. So 1/2 cos minus cos. 1/2 cos of alpha minus beta minus cos of alpha plus beta. Alpha, beta, alpha, beta. Leave myself space to write those angles in there. Words are hard today. I think I left my brain in San Jose yesterday. So substitute, yeah? Alpha is 9b, beta is b, 9b, b. And we simplify. 1/2 cos, and 9b minus 1b gives me 8b minus, and then cos, oops, 9b plus b should give me 10b. And I don't think we can make that any prettier. I think that's it. A warning from what I saw this morning with my second period is that 1/2 is times the whole thing behind it. So you either need parentheses around the whole subtraction piece, or you can distribute it and then each cosine would get a 1/2. But what I saw a lot of this morning was people deleting the parentheses and not distributing. And so they had a 1/2 cosine and then a whole cosine, which is not what the formula says. Formula says 1/2 of the whole thing. So make sure you're paying attention to that when you're writing today. Yeah. Okay, how are we feeling about that process? Grabbing a formula, substituting angles, simplifying. I see nodding, I see thumbs up, I see kind of shaky. We're going to do the other direction. We'll see if that helps. Yeah? Let's try the other direction. Let's scooch you up here. We'll do number 6, because that's right in front of me. Number 6, directions say write each sum or difference as a product. We're going the other direction. And we have 2 times cos of 18 theta plus cos of 4 theta. So this is a sum of cos plus cos. So we go to the sum to product formulas and we look for cos plus cos. And I know that that 2 in front's just going to come along for the ride. I'm only substituting in the formula for the cosine plus cosine. And I know my first angle is alpha, my second angle is beta when I make that substitution. Yeah. Okay, so cos plus cos. Cos plus cos is 2 cos with a fraction times cos with a fraction. And those fractions are alpha plus beta over 2 and alpha minus beta over 2. And now I just need to plug in the alpha and the beta. Right? I left a blank for each. So my alpha is 18 theta. My beta is 4 theta. 18 theta, 4 theta. We're going to simplify. And this is like college math. So we're going to do all of the simplifying in one step. Yeah. So we'll work our way from left to right. 2 times 2 is 4. In the first cosine, 18 plus 4 is what? 22. And we're going to take the 22 theta and divide it by 2, which I'm pretty sure gives me 11 theta. I don't see any argument. I'm assuming I did that right. And then we do the same for the second cosine, times cosine. And then we have 18 minus 4, which is 14. So 14 theta over 2, and 14 divided by 2 is 7. So 7 theta. Yeah, that's it. That's it. Grab the formula, substitute the angles in, simplify the expression. Yeah. Individual skills we've got, now we just got to squish them together. We got this. We got this. And I saw some of you yesterday were good about doing that quizzes, which was practice with this. Yeah, good. I would like to take just a second to do one more of the number problems at the bottom of the page, because I think that's where the struggle was this morning. And then I'll set you loose to practice. Yeah? Okay, so looking at the bottom, we've got 5 of those. Which one looks the scariest? Which one do we want to see? 11 looks scary? Okay, let's do 11. I didn't mean to zoom out quite that much. All right, so we're going to tackle 11. So, two things. I identify the angles, my alpha and my beta. I identify which formula I'm using. Yeah. So alpha always comes from the first trig function, so my alpha is 25 pi over 12. Beta comes from the second guy. Beta must be 17 pi over 12. And this is cos plus cos. Cos plus cos. So we're using a sum to product. I have a sum, I'm going to turn it into a product. Yeah. I know the coefficient in front comes along for the ride, so I'm going to have minus 5 times, and then whatever my cos plus cos formula is. And I think we just used this, didn't we? Cos plus cos is going to be 2, and then it's going to be times cos, and then we get a fraction of alpha plus beta over 2 times cos with a fraction of alpha minus beta over 2. And we just got to plug in our alpha and our beta. So my alpha is 20, yeah, no, I didn't need to do that, 25 pi over 12. My beta is 17 pi over 12. 25 pi over 12, 17 pi over 12. Ugh. And this is kind of like the last problem. I should simplify first, because I have an expression inside that trig function. I should make it pretty. And then I should use the unit circle to evaluate those cosines. What do those cosines equal? Yeah? So let's simplify first. And I'm going to do that off to the side. This is going to involve some fraction math. So that first fraction, I have 25 pi over 12 plus 17 pi over 12 all over 2. In the numerator, what is 25 plus 17? $42. So that's going to be 42 pi over 12 over 2. We're going to reduce the numerator before we deal with the over 2. Yeah? So in the numerator, what are 42 and 12 both divisible by? Think bigger. I agree with 2. I don't think 4. 6. Yeah, I think they're both divisible by 6 because they are divisible by 2 and by 3, which means they're divisible by 6. So what is 42 divided by 6? Get 7, yeah, so we're going to get 7 pi, and then 12 divided by 6 is 2. That looks way less scary. So 7 pi over 2 over 2. And I know when I'm dividing by a whole number, I can turn it into a fraction over 1. And when I have a fraction divided by a fraction, we keep the numerator, we flip the denominator. And we multiply straight across. So my numerator is going to be 7 pi. My denominator is going to be 2 times 2, which is 4. Which is way less scary than what I had to begin with. 7 pi over 4. Is 7 pi over 4 on our unit circle? Yes, that's good news. So we've just rewritten this as something we can tackle. So let's come back to this step. Negative 5 times 2 is negative 10. And then I'm going to have a cosine of 7 pi over 4. And now it's that second cosine that I've got to deal with. Same idea, yeah? Except now instead of addition, we're going to do subtraction. Before I do that, did everybody get this part down with the fraction math? Okay, I'm going to erase it. I'm going to do subtraction in the same spot. Okay, so for subtraction, we're doing 25 pi over 12 minus, 17 pi over 12. Why is that all weird? Ew. Wait, no, stop. That was weird. 7 pi over 12 minus 17 pi over 12. And first question, 25 minus 17. Is that 8? 8? Okay. So 8 pi over 12. That's less scary. What are 8 and 12 both divisible by? 4, yeah. So that's going to become that's a 4, that's a 4. So that's going to become a 2 pi over 3. And that was all over 2. And so same process, right? Bottom over 1, keep the first fraction, flip the second fraction. And I see something that cancels when I write it that way. I see a 2 on top and a 2 on bottom. What happens to those 2's? What am I left with? Yeah, just pi over 3. Pi on top, 3 on bottom. Is pi over 3 on our unit circle? Yay! That's good news. Pi over 3. All we're going to do is grab those values off the unit circle. I got a minus 10. I've got a fraction that's going to come from cosine of 7 pi over 4. And I have a fraction that's going to come from cosine of pi over 3. So on our unit circle, we go to 7 pi over 4. 7 pi over 4 is in quadrant 4. And we know cosine is the x-coordinate. What do we get for cosine of 7 pi over 4? Root 2 over 2. Very good. So this is root 2 over 2. For cosine of pi over 3 is in quadrant 1. We want the x-coordinate, which is 1 over 2, 1/2. Perfect. A reminder, the whole number out in front, that negative 10, is negative 10 over 1. And when we multiply fractions, multiply across the numerator, multiply across the denominator. So I have a 10 times a 1, that's going to be negative 10, and then the root 2. In the bottom, I have a 1 times a 2 times a 2, which is 4. And I should double check, can that be reduced? Can negative 10 and 4 be reduced? Yeah, what are they both divisible by? 2. Yeah. So negative 10 by 2 is negative 5. 4 by 2 is 2. And that is exactly correct. Yeah. Yes. Oh, so technically I multiplied all of these together, but I grouped the whole numbers together in front because I can't squish the 10 and the root 2 together. So they're still being multiplied. I just can't simplify it any further. Yeah. Now that was a good question. Typically, if you're multiplying a big string and you've got whole numbers and radicals, whole numbers together in front, radicals behind. And we write them as a multiplication problem because you can't do anything else. Yeah. Other questions? That was a good question. Okay, so to review before I set you loose, the first part was exactly the same as the upper half of the worksheet, right? We identified our angles. We identified which formula we were grabbing, cos plus cos. We substituted our angles into that formula and simplified. That got us here. From here, that was when we grabbed the unit circle to evaluate the cosines and then had to simplify again. So this is the top half of the page with just 2 extra steps at the bottom. Unit circle and another simplification. Yeah? We can do this. We can do this. You have the rest of the class period to work on that worksheet. If you find you're running out of space, particularly with those last 4 questions, the back side of the paper is blank. You can do them on the back. Yeah? You've got your unit circle. We have a small class today, so if you want to move to sit next to someone else, that's fine. If you have questions, let me know. Yeah? Otherwise, this is what we're doing today. Get some practice.